Hello, I am Nitesh Pradhan from LabVIEW and Multisim. It is fourth number video of the LabVIEW Flex Logger tutorial, NI Flex Logger tutorial. In this video, we will learn how can we configure a channel in Flex Logger. Means if I want to acquire a voltage, current, and temperature, so how can I configure that channel for data acquisition? We will learn that things. So let's start. Now, so for that you need to open your Flex Logger. When you will open your Flex Logger, okay, first open your Flex Logger. When you will open your Flex Logger, so you will get a window like this. Okay, it is entry window of your Flex Logger. Before going to create any project in this Flex Logger, we need to check the hardware is present or not in our PC, or hardware is configured or not. So now you can see here the three. Now you can see here I had created one virtual hardware USB CDAQ 9174, and along with the 9174 I have 9213, 9215, 9232. 9213 is for the temperature, 9215 is for the voltage, and 9232 is for the sound and vibration. So three virtual hardware are available on my PC. Now here I am going to click file, create a project. Now the project has been created, and my system is configuring all the hardware which is present on my PC. Now you can see here. Okay, so now you can see there's four counters. In 9174 we have four counters: counter 0, counter 1, counter 2, counter 3. We have four counters, so I am going to minimize this counter, and as per after the counter I have a 9213, which is, okay, sorry, 9213, which is temperature module, 9215, which is a voltage module, and 9232, which is a vibration module. Okay, counter speed is 1 kilohertz. Okay, temperature I can vary from the slow to high, slow to fast. Voltage I can vary from the slow to hard, and also we can vary our vibration from slow to hard, slow to fast. So now slow is 1 hertz, medium is the 100 hertz, and fast is the 1000 hertz. Let's go into the channel configuration. Now you understand how can we configure our hardware. So our next topic is channel configuration. Here I want to measure only one channel temperature. I want to measure one channel temperature, one channel voltage, and one channel acceleration. Okay, so that means one channel. So for that, come into the AI0, click here, AI0, and click here. Come into the AI0 and click here. When you will click, you will come into the configuration window. Now here measurement name is, okay, measurement CDAC module 1 AI0, and I want to measure the temperature. I want to measure temperature. Why? Because in module number one it is temp. Okay, let's try to check it. Temp is connected, right? General info, temp is connected. Temperature module 9174 is connected. Okay, so whatever 9173, okay, 9173 module is connected. So I can 9 sorry ni 9213 ni 9213 is connected. 9213 ni 9213 temperature. Sensor class is thermocouple. It's clear. 9213 temperature class is thermocouple. Physical measurement is thermocouple. Sorry, temperature. Now you can see here there is different other things, but measurement is temperature, and sensor class is thermocouple. It will be coming with degree centigrade. Okay, scaling will be the linear, and slope will be the 1 degree centigrade. Okay, and CGC, cold junction compensation, is the inbuilt thermocouple. Okay, now you can see it's generating the data. It's continuously generating the data. What kind of data is generating? It's continuously generating the value. Okay, now let's see how can I configure a voltage. So for the voltage configuration, double click and come here. Now my voltage module name is NI space 9215 slash AI0, and my physical measurement will be a voltage. Physical measurement will be a voltage. Now the sensor is a voltage type. Okay, value will come into the volt. Okay, and the value range is plus minus 10 volt, plus minus 10 volt. It is linear. Slope is 1 volt 1 per 1 volt per volt. Okay, slope. And the range is hardware range is plus minus 10 volt, and the terminal configuration is differential. Coupling is DC. Press OK. Now you can see my system is running. Now system is not stopped. The system is okay running. Okay, sorry, system. Now the system will run. Now you can see my system is running and it's measuring the data. It's measuring the completely data. Both the system are measuring the complete fine data. Okay, let's come into the third. I am going to press and stop here. Now you can see automatically it's generated the TDMS file. We'll check it later. Automatically it generated TDMS file. We'll check it later. Now come here and AI01 channel I configure. Here I am going to not change the name. Here the deck mode will be the same, and the physical measurement will be a acceleration. Acceleration. Uh, yes, acceleration. Physical measurement will be a acceleration. Now the sensor is my IEPE. The sensor is IEPE type of module. Okay, IEPE type of module. Suppose I have uh, PCB based triaxial monoaxial acceleration sensor. Let's go. You can see here I am getting the value. I am getting the value in Z. I am getting the value in okay Z. So now you can see here. Uh, Here I am able to measure the current here, sorry, voltage. Here I am here I am going to here I am able to measure the temperature. Here I am able to measure the voltage, and here I am able to measure the temperature. Okay, sorry, acceleration. Now I think there is something wrong, so here I am going to set it again, delete. Here I am going to again set. Now come here for the voltage measurement channel will be a voltage. It will be a voltage for me, and sensor will be a voltage again. Everything is fine, everything is correct. Okay. Mhm. Here I am going to click in the millivolt range. Okay, millivolt range. Press the OK button. Now here we are here you can see this one and this one, all these three are working. This one, all these three are working here continuously. I am able to acquire, I am able to see the data. I am able to see the data of this one. I am able to see the data for this channel. I am able to see the data for this channel. Okay, using this we can see the data. Using this we can acquire the data, right? When I will start run, when I will run the program, it will create, when I will run a program, so it will create a TDMS file. Automatically it will create a TDMS file inside my data logger. So now here I am going to run the program. Now the time is 22, okay, 27, 5:15. Okay, 5:15 time, 5:15. So let's run. It's loading, and now you can see 5:18. The data acquisition time is 5:18. Here I am going to check my document. Inside the document there is flex logger, and flex logger inside the data there is 5:18. There is no any TDMS file path. There is no any new file has been generated for 5, okay, after 5:18. Now when I will stop it, so now you can see here the prop, okay, it has been generated, and it's okay, and it has been saved. Whatever the data I had acquired, I can check that data here. So it is my TDMS file. This TDMS file has been generated after this. So, and we have logged, you can log all your data. You can, now you can see it is 317k B data. You can acquire, you can log all the data. If you want, so you can remove. Yes, you can remove. You can remove. So thank you for watching this video. Using this video, I think you are able to understand how easily we can configure our channel. If we don't know how to write a program, okay, and we want to measure data, so how can we easily measure the data, easily measure the channel data from the sensor? You can. In the next video we will use the screen and we'll see how can we display our data in numeric form. Okay, so thank you for watching this video.